Right now, somewhere in your house, a thermostat is quietly deciding your fate. You tap a button, the temperature climbs 2 degrees. You don't even look up from your phone. It feels like nothing. But the real answer to how humans handle cold is far stranger than a button on a wall. 40,000 years ago, your ancestors faced winters that could kill you in under an hour. No walls, no fire that always caught, no fabric store. Just skin, fat, and a brain that had to outthink the weather or die. And somehow, they didn't just survive it, they spread across it. They walked into Siberia, they crossed into the Arctic Circle, they lived through ice ages that buried entire continents under sheets of frozen water thicker than skyscrapers are tall. How? The answer isn't really about strength. It's not about thick skin or built-in fur, because humans don't have either of those things. You are, biologically speaking, a tropical animal. Your body is optimized for African savanna heat, not for blizzards. So the story of how your ancestors beat the cold is really a story about how they cheated biology using something almost no other animal on Earth had. Start with the obvious problem. A human body loses heat fast. You have very little insulating fur. Compare that to a wolf or a mammoth or even a rabbit. Those animals grow a coat that adjusts with the seasons. You don't. Evolution never gave you that option. Instead, your ancestors got something else, a brain wired for invention. Researcher Ian Gilligan, an archaeologist at the University of Sydney who has spent years studying the deep history of clothing, argues that this invention wasn't casual, it was survival technology, and it changed everything. Gilligan's research suggests that tailored, fitted clothing didn't appear because someone thought it looked nice. It appeared because certain populations of early humans hit cold environments so severe that loose skins draped over the shoulders simply weren't enough anymore. Picture it. A cold snap rolls in. The temperature drops far below anything your body evolved to handle. Loose hide wrapped and tied still lets wind slip through the gaps. Heat leaks out at the seams. People are dying of exposure, even while wearing something. So something changes. Someone starts cutting the hide into shaped pieces. Someone starts stitching those pieces together so they hug the arms, the legs, the torso. Suddenly, there's a layer of trapped, still air between your skin and the outside world. That trapped air is the real insulation, not the material itself, but the pocket of warmth it holds against your body. This is where the story gets stranger than most people expect, because to make fitted clothing, you don't just need hides, you need needles. And bone needles with tiny eyelets, fine enough to pull sinew thread through leather, start showing up in the archaeological record right around the coldest stretches of the last ice age. Some of the oldest examples come from sites associated with Denisovan and early modern human activity in Siberia, dated to roughly 40 to 50,000 years old. Think about what that object represents. A needle isn't a weapon, it isn't food, it's pure foresight. Someone sat down cold and solved a problem that wouldn't even happen until tomorrow, or next week, or next winter. That's not instinct, that's planning stretched across time, and almost no other species on the planet does that. But clothing alone doesn't explain everything. You still need to ask a harder question. What about your own body? Because your body wasn't just sitting there doing nothing while your ancestors sewed. It was adapting too, in ways written directly into your biology today. Anthropologist Eric Trinkhaus, who has spent decades analyzing Ice Age human skeletons, has pointed to something remarkable found at a site called Sunghir in Russia, dated to around 34,000 years ago. The burials there include bodies covered in thousands of carefully placed ivory beads, arranged in patterns that match the outline of fitted garments, hats, and even shoes. This wasn't survival gear thrown together in a panic. This was tailored, decorated, socially meaningful clothing made by people who understood exactly how to keep a human body alive through brutal cold, and who had enough stability in their lives to also make it beautiful. Now here's a question worth sitting with. If clothing worked that well, why does your own body still carry cold defenses at all? Why do you shiver?
Why do your fingers turn pale and clumsy in the cold, redirecting blood towards your core? Because clothing was never the whole plan. It was one layer of a system. Your body still runs an ancient backup protocol. When your core temperature drops, blood vessels near your skin constrict, pulling warm blood away from your extremities and towards your vital organs. That's why your fingers go numb before your chest does. Your body is making a calculated trade. It sacrifices your hands to protect your heart. Some human populations push this even further. Researchers studying indigenous groups who have lived for generations in extreme cold, such as certain Arctic populations and freediving communities in cold water environments, have documented physiological differences that look almost engineered. Faster rewarming in exposed skin, different patterns of blood flow to the extremities. These aren't things you learn, they're things your ancestors' bodies were quietly selected for, generation after generation, in specific environments where getting it wrong meant frostbite or death. And then there's fire. It's easy to take fire for granted, the way you take a thermostat for granted, but controlled fire is arguably the single most important survival technology your species ever developed, and evidence for its consistent, deliberate use stretches back at least 1 million years based on burned bone and sediment analysis at sites like Wonderwork Cave in South Africa. By the time your ancestors were pushing into truly frigid environments, fire wasn't a discovery anymore, it was infrastructure. Shelters were built around hearths, group sleeping arrangements were organized to trap radiant heat, entire daily rhythms bent around keeping a flame alive through the night, because a fire that died in January could mean a group that didn't wake up. There's another piece of this puzzle, and it's sitting inside your own cells right now. Fat isn't just fuel. In cold environments, it becomes armor. Your ancestors who pushed deepest into frozen landscapes needed calorie-dense food and lots of it just to keep their internal furnace burning. Researchers studying Ice Age diets have found that populations in cold, high-latitude environments relied heavily on fat-rich meat from large mammals like mammoths, reindeer, and horses. Not because they preferred it, but because fat contains more than twice the calories of protein or carbohydrates, gram for gram. A body burning through energy just to stay warm needs a fuel source that dense. Lean meat alone, without enough fat, can actually be dangerous in extreme cold. Some researchers call this rabbit starvation, a condition where a body forced to survive on lean protein alone during winter can waste away even while eating regularly because it lacks the fat needed to metabolize protein safely and generate enough warmth. So your ancestors hunted differently in the cold. They targeted the fattiest parts of an animal first: marrow, organ fat, blubber in regions near the coast. Bone-cracking tools found at cold climate sites showed deliberate, repeated fracturing of long bones, evidence that people were digging out every last calorie of fat hidden inside. That wasn't wasteful, it was precise. It was the difference between a body that could hold its own heat through the night and one that couldn't. And your body still carries a strange, quiet echo of this system. Tucked around your neck, your shoulders, and your upper back, you carry small deposits of something called brown adipose tissue, often just called brown fat. Unlike the fat that stores energy for later, brown fat has one job: burning calories directly to generate heat. Researchers studying cold-adapted populations, including work on Arctic and high-altitude groups, have found that people who regularly experience extreme cold tend to retain more active brown fat than people who live in consistently warm, climate-controlled environments. Babies are born with a lot of it because a newborn can't shiver effectively yet. Most adults today have very little because most adults today are never cold enough to need it. Which raises an odd thought. The reason your body barely uses this ancient heating system anymore isn't because evolution removed it, it's because your environment removed the need for it. You carry the same emergency furnace your ancestors relied on in the depths of an ice age. It's just been sitting unused, waiting for a cold your thermostat never lets it feel. Here's the part that should genuinely surprise you. Cold didn't just push your ancestors to survive, it pushed them to cooperate. Anthropologist Rick Potts, who studies how unstable climates shaped human evolution at the Smithsonian's Human Origins program, argues that some of the sharpest jumps in human adaptability came not from stable, comfortable environments, but from wildly unpredictable ones. Extreme cold is exactly that kind of pressure. You cannot out-muscle a blizzard, you cannot outrun a Siberian winter, but you can share a fire, you can trade a spare hide, you can teach your children to sew before they need to know how. Cold, in other words, may have quietly built some of the deepest instincts you still carry. Your instinct to share resources with people close to you, your instinct to plan ahead instead of living moment to moment, your instinct to trust the people huddled around your fire more than strangers outside its light. None of that started as kindness for its own sake. It started as a survival algorithm running inside a species that had no fur and no claws and no natural defense against freezing to death except each other. So think again about that thermostat on your wall. It feels disconnected from all of this, doesn't it? A silent, effortless button, but it's really just